Okay, how's everybody doing? Welcome back to another week of the DSKUS program, recording here our next little lecture. So I'll try to go through this pretty quickly. It's actually a holiday here in Korea, so I'm not in the office. I'm actually at home. It's Children's Day, so celebrating a little one-day holiday for all the small people in the world, all the children. So yeah, but today we're going to talk through something that I've noticed on pretty much all of the design sketches I saw and a lot of the proposals that I've seen related to how the information is going to be used. And I think this is a thing where every single group can improve on. And in general, this is an issue in all data science projects. At some point, we have to be able to give the information to people and they have to be able to use it. But that means that we're going to have to create infrastructure to provide the information back to those users, to those people, whoever they may be. And you guys probably saw some of that feedback in your design sketches related to, who's going to look at this? How are they going to use it? Is it going to be government officials? Is it going to be private citizens? What about business people? Other groups of people, depending on your project topic. And this is something I think every group needs to give some more thought to. So we're going to kind of talk about some ideas about how we can do this. But in general, in data science, this is a problem. If all we have is a model, that does some analysis, then how are people going to actually use that to make decisions? Data science is not about building models. It's about helping people make better decisions. It's about improving human decision making. And so if we can't get the information back to people, then we haven't really achieved the goal of data science. We have a model, but unless we're just academics in the lab trying to do research, we haven't actually created anything that people can actually make use of to make better decisions. So in a data science sense, we have to kind of realize that all solutions need to persist over time, right? We're not doing some one-off analysis. I mean, sometimes we are, but that's not really a data science solution. That's just this one-off analysis we did. All of our actual data science solutions are going to need to persist over time. They're going to need to continually take data in and then push information out to some users, whoever those may be, right? And that means we have to plan for this, right? This has to be part of the data science process when we're doing data science projects. We can't just worry about analyzing the data because then we haven't really accomplished the goal, right? Or at least not effectively, right? So thinking about planning for this, kind of related to things we've talked about in some previous weeks, but kind of moving forward, is we have to think about these data infrastructure components, right? And you'll notice that in this little schematic here, analyzing data is one part of what we do, but there's all this other stuff we need to consider. We need to think about how these analyses then become like sort of AI models or some sort of algorithm, and then those algorithms or models then become deployed solutions. And what does that look like? Is there going to be an interface, a website, some sort of smartphone app on your device, right? Maybe we'll actually put embedded devices into factories, right, to fight climate change based on some model, right, to change some sort of process, right? We could do those kinds of things, right? And we may want to actually then also think about the data being collected. Maybe we should collect more data than we have right now because maybe our analysis reveals gaps in our knowledge, right? So then we'll need to think about, well, what kinds of sensors do we need to collect that kind of data? Where's that data going to be stored? The kind of databases or cloud systems or whatever. And so there's all these other steps outside of the analysis. And I want to encourage all the groups as we get into this final month to really give this some deep thought. The analysis is one part of what you're going to do, but in order to create a solution, we have to think about all this other stuff. And if we're not thinking about all this other stuff, then we're not really being successful as data scientists. We're kind of failing, right? We're not doing the whole job. We're just doing like a part of it. And we really want to think about all these different steps about taking our analysis and creating something that can actually persist, can actually last in the real world, right? I like to think, I always describe these sort of data ecosystems, these data infrastructure components as sort of kind of data ecosystems, right? And they're just like natural ecosystems where you have all these different components and each one's important. It's the ambulance outside, obviously, but each one of these is important, right? If we remove any one of these, if we remove like the fungi here, like the mushrooms, or we remove the insects or the algae, the whole system changes and it may actually just collapse. So we need to think about the entire system, right? If we only think about one part of it, then we're not really creating this ecosystem. Data and data science is about creating these data ecosystems. Also, randomly, there's a kangaroo in this picture too, if you notice. I don't know why, but there is. So these data ecosystems, these pipelines of data, they're really like basically places for data and our models and our solutions to inhabit. And there's essentially a bunch of different components that are going to be talking to each other. And they're just like these natural ecosystems, right? And so we have to kind of think about all these different components. And there's lots of different, components that can exist in these ecosystems, right? We can have data sources, we can have places to store the data. We have networks and interfaces, so there has to be some way for computers, different parts of the system to talk to each other. We have our analytical software, right? You may be doing stuff in Scikit, right, or R or whatever, right, analyzing data. And then we have our visualization and reporting tools, right? Maybe you use Tableau, or maybe you do stuff in Seaborn and Python, or ggplot and R, or whatever the visualization or reporting tool that you might choose. But there are going to be many different components that we may want to create or utilize when we're kind of thinking about our systems, our data ecosystem. So going back to a lot of your design sketches, you can kind of start to think about, like, you got pieces in there, but there's probably some other stuff in there that we need to think about in terms of the infrastructure and the components that maybe we need to make a working solution that we can deploy, right? Another thing to think about too, and I've noticed in a lot of your design sketches, a common issue is a lot of times we have data coming from different sources. So another thing we need to think about is integrating that data, right? Doing ETL processes and kind of data warehousing stuff, getting data from different sources into one sort of unified system is not easy, right? And this is why data engineers get paid so much money, right? When we integrate data from many different sources, there are often many different problems, right? Simple things like data in different formats, different column names. Sometimes you have the same person with two different names, one person, but they're named differently, different timestamps. Sometimes you have just bad data, missing fields. These are all things we have to kind of think about. And so we should kind of plan for this in our sort of design sketches that we're going to be using to try to solve our problem when we think about our final solution. So as you guys are thinking about this over the next month, these are all things for you to kind of consider, right? These are things that you want to kind of think about. What's missing in our proposal so far, and where are the gaps, and how can we fill these in to actually make a working system that we can deploy, as well as, especially for a lot of you guys, a big missing piece was this last kind of stuff with the interfaces and the visualization. Like, what are people actually going to see if we're going to have some output? Like, what is that output going to look like, and how are they going to use it? How is it going to help them make better decisions, right? Another thing you guys can think about doing is actually doing what's called resource needs assessment. When I was a practicing data scientist, we did this kind of stuff a lot, not always exactly like this. This is one example, but trying to figure out what the actual end user needs so that we can try to design something that they can actually use, right? A lot of times we, in our heads as data scientists or designers, come up with our own plan, but that's not what actually people want to use. And then we build what we think, and we build it, we give it to them, and nobody uses it, right? So that's a bad idea, right? you're wasting your time building something that nobody wants to use. So we may want to try to figure out what people actually use, either by going and asking them, which is sometimes helpful, or also by just sort of like observing like what people do or studying what people do in certain contexts, and then trying to understand like what are the criteria that we're trying to hit, what are like the things that people do like currently when they're about to make a decision about these things, and then how can we create something that fits into that process. Again, it's got to fit into what they're doing, and nobody's going to use it. They're going to look at it like a space alien, right? So one thing we need to do is think about, okay, what are people actually doing when they do this thing, when they make a decision about this thing, or when this process happens in human society, right? When people choose what kind of car to drive, or when people choose like how much to drive, a vehicle, right? Or whether they should purchase an electrical vehicle or not an electrical vehicle. How are these decisions being made? And what are the sort of factors that are influencing them? And how can we create an interface or some sort of tools that fit into that thought process that people will actually use, and it'll help them make better decisions, right? So resource needs assessment, right? And there's lots of ways to gather data here. You can just do some analysis by studying trends and evaluating current systems. You can interview people. Probably in the scope of this class, that's probably not going to happen because we don't have enough time to do it, but maybe you could just talk to people about certain issues and gather data that way. You could run focus groups. Again, probably not going to happen in this class because we don't have time, but you could gather people together and get them talking about an issue or problem, and then pay attention to what they're saying and record it, and then study what they're talking about and try to derive from that sort of themes or content that you can use to guide your design process. You can also try to create personas of like sort of simulated users. You can create use cases, right? Where you kind of just, kind of set up your own scenarios. You can do case studies where you just literally go follow people around. I used to do this when I was a data scientist and I was building clinical tools. I would go watch doctors and patients have like a clinical session. I would go sit there in the back of the room and just be real quiet and observe them. I mean, I told them I was there. I wasn't being creepy, but I was like, yeah, I'm going to observe this session. I would sit there and we record it and we record all this data, and we try to understand what the process was so we could build things that would actually be useful and that people would use, right? You can also think, in a physical design standpoint, people kind of talk about design specs. Like, what are the features that our tools need? What do they need to include? What kind of aspects, right, to fit the user needs, right? So you can also think about kind of creating design specs for whatever tool you're going to create. In other project-based classes, my students, when they get to this stage, I usually always say something similar to this. I'm like, that's great, you're building a model. Nobody's ever going to use that model because you don't have any way to deliver the information back to your users. Well, for a lot of people then, as they start to think about what are people going to do, what's the process, what tools are we going to build, or what's going to be the output of our models, like of our solution, like what are people actually going to see? What are the end users going to interact with? One thing you can do is actually create sketches there of these things, like so sort of prototype them, right? And this is very commonly used in human computer interaction, HCI, or also in my field, human robot interaction is mostly what I do. So we often create these sketches, wireframes, different types of tools, and they're pretty cool. One of my favorite ones is Balsamiq. But there are a bunch of these. There are actually dozens of these. You can Google search online for wireframe tools on the internet, but I think Balsamiq's a pretty cool one, but you can pick your favorite one, whatever you want. But you can create really cool sketches of things, these wireframes, and you can create like websites, create smartphone apps, different kinds of visualizations, graphs, interfaces. And what's cool about it is you can even actually, so you can mock these prototypes up. And what's cool is they even can kind of be kind of interactive, where you can actually put buttons on certain screens, and when you click the button, it'll go to the next screen. So you're not really building the app or the website, but it's essentially a prototyping tool to see what it looks like and to kind of observe how different functionality would work, right? Like, so if we click on something and it goes to the screen, does that make sense? Or should we have like a slider here or a button, right? Or how should these things be connected together? And so it's pretty cool. So you can kind of create these sort of these interactive prototypes and kind of experiment with different data visualizations. And for a lot of you guys, you don't have to do this, but I think in terms of kind of thinking about the output of your model, of your solution, and thinking about what are the end users going to see, right? These are great tools to help you kind of explore those ideas, right? We have our machine learning model. It produces this analysis, and here's our output. But then what are we going to then deliver back to policymakers, government officials, maybe business people, private citizens? Sometimes private citizens, we want to influence their decision making. Like, what are we going to actually show them? What are they going to see, right? And again, you don't have to do this, but I think it's a good habit to get into in data science, is thinking about sort of the full 360-degree process of the whole solution, from the data to the analysis to turning that into algorithms, and then turning that into some sort of actual solution, some output that people can interact with. And these are pretty cool, pretty fun to work with. And it's, you create your own prototypes, and it's pretty interesting. So I would encourage you guys to explore some of these things over the next month as you kind of try to get to the end of your projects. And you don't have to, but good to think about. Another thing I mentioned here, and I mentioned this in some of my classes, is the sort of data engineering side. So one thing we also need to think about is deployability, right? We want our solutions to actually be things we can deploy, right? So, sometimes in data science, we build models and we have like this really cool deep learning model that takes 3 days to run, or however long, or you can run it maybe in 4 hours, but you have to have all these cloud computing resources. Or we build a solution that works right now, but if anything changes, it just breaks, right? So we want to think about making something that's deployable, because if we can't deploy it, it's useless. And the other problem is the world changes, right? And I'll talk about this more in a second, but the world is always changing. So if we build a solution for today, that solution may not make sense tomorrow, right? Or maybe next month, or 6 months, or a year, 5 years, right? However long. Eventually that solution is not going to make sense unless we can update and maintain it to adapt to the world, because the world is always changing. So that's what we're talking about with deployability, is we want things that are, deployability is generally defined by these 3 pillars, right? It's got to be scalable, it's got to be reliable, it's got to be maintainable, right? And each of these has definitions. But in general, like, we need a system that that one is scalable. So as we scale it up and more users need to use it, or we need to have more resources that can deal with that, it needs to be reliable. So just because one thing breaks, the whole system doesn't collapse, right? So just like when you're in an airplane, if one engine fails, the pilot can still land the plane, right? In fact, even if all the engines fail, the planes are designed in a way that an experienced pilot can actually still possibly land it, even if all the engines are failed. In fact, if you take flight lessons, they teach you that, how to land a plane even when all your engines fail, right? And planes are designed for that. And the other one is maintainability. Again, we need to be able to update and maintain our solutions. Otherwise, they're not going to be valid anymore. In just a few months, like, something will have changed, and now our solution is, we just wasted all of our time building something that no longer makes sense. And we don't want to waste all of our time spending months building something that might be irrelevant in 3 months. That's kind of pointless. So the other thing to keep in mind is that systems are not going to be used as intended, right? One thing that I had to learn that was kind of eye-opening to me in my early data science career is I would build a data science solution thinking that it was going to be used like this. And then once I got done and gave it to the users, they used it like this. And it may be similar to what I had thought, but different. It's always different. It's never what you think. And so we need to kind of plan for the system to have these flexibility so that the users can take it and kind of use it in the way that makes sense to them, right? Users are going to adapt our designs to their needs. And so if our design is too rigid, right? If our design is too rigid, then people are going to have a hard time using it. So we want to make things flexible so that they can be adapted to what people actually need, as well as maintained and changed as the world changes, right? And this is a kind of a major issue. I see so many data science projects in the business world, you know, as well as in class sometimes. I see them fail because they don't do this. They build something that's so rigid that in a few months it's no longer relevant, you can't change it, or the users, you know, they try to fit it into how they work and how they think, but they can't because it's not flexible enough to allow for that. We have to plan for the things that we create to be adapted to fit user needs, right? Basic tenet of HCI and HRI, and we have to do that in this class as well, right? General rule, I'll just mention this really quickly. The more complex things become, the more rigid and more fragile they are. So in general, it's good to keep things simple, keep it simple, stupid, KISS, right? Because we always might want to add more complexity later, but if it's already too complex, then it becomes very difficult to do that. So we always want to think about ways we can simplify parts of the process to make them easier to maintain, right? Related to this, kind of, and probably more specific from a data science, from a policy, data science policy standpoint or policy making standpoint, is this issue of sustainability, right? So sustainability is a big deal in policy making. And we can think about that in different ways. There can be sort of environmental sustainability, in terms of like the impact on the environment of certain policies we make. And there can also be social sustainability, right? So every policy we put in place as a government or governing organization is going to impact the way people live. It's going to impact human communities, right? And people, whether we realize it or not, we often are disconnected in the modern world. We depend on our environment to survive, right? We got to breathe oxygen, we need water, we need food, but we also depend on our communities to survive, right? No man is an island, right? In modern society, and even in prehistoric society, people are social animals, right? Right? Like all primates. And we depend on our communities to survive. We don't survive on our own. Maybe for brief periods of time, but we always come back to the town, the community, you know, the village, like to trade or whatever. Even the mountain men would do that, right? They go off for weeks at a time, but they come back eventually because we have to. We survive as a social group. That's how humans are. That's how we evolved. And so social sustainability, environmental sustainability, probably other types of sustainability too. But these are things that we have to think about in this particular class, because sustainability is a balancing act. It is a balancing act, and we have to think about in the long term. Every time we try to do this, well, then now this thing has been affected, right? If we try to save environmental resources, well, now we might hinder the economy, and we're going to reduce human resources, right? Or we're going to disrupt, you know, human communities, human social systems that exist right now, human networks, and that might damage people in ways that we don't realize, right? And it might damage, you know, people's opportunities. It might damage people's, you know, sort of economic, you know, opportunities. It might damage people's ability to survive in other ways. So we need to be very careful and think about, you know, a policy that there are policies that might protect the environment, you know, in rich countries that lead to people starving to death in poor countries, right? Or in another region, maybe different regions, different communities, or policies that increase economic exports might actually create greater income inequality. I should say inequality here, larger income inequality in a society. And this often happens. This is actually a big problem in Korea, right? Where there's a large amount of income inequality, and a lot of it's related to the way the economics are set up. And it's a heavily export driven economy. So we have to think about, there's always these trade-offs. And we have to think about, just because this improves one thing, well, okay, what is it gonna interfere with or disrupt? There's always a trade-off. There's very rarely in life a win-win situation, right? So Another thing to think about, and this is it's a topic called policy integration. So if we have two government agencies and one's doing this and one's doing this, well, then we have these incoherent policies, and often that leads to unsustainable practices, right? A lot of times it's not just the trade-offs that cause a problem, it's that one government agency is doing this and one's doing this, and now everything's all messed up, right? So I'm not going to say too much more about this, but if you guys are curious about this, there's the toolbox we read at the beginning of class. It talks about sustainable development, these issues of sustainability. There's also a couple great resources here from the EPA and the OECD that talk about creating sustainable solutions, both socially sustainable and environmentally sustainable. Again, both of these are important. Just because we do something that benefits the environment, if we cause catastrophic damage to social networks, if we disrupt human communities and people have a hard time surviving, right, then we've caused damage, right? We caused damage one way or the other. So we need to think about sustainability very carefully when we come up with our policy proposals. If we propose something that's not sustainable, well, then, we're going to look like idiots. So let's think carefully about these topics and think about it. So the project proposals are due this week, I believe. So right after your midterm updates, and then I believe after that we'll have some traveling and some other things, and then we'll kind of get into the last few weeks. And the last couple of weeks there, the semester, mostly us kind of preparing to do the final presentation and putting everything together, and kind of thinking about how we kind of present our sort of research, our projects, and how we kind of persuade people that our ideas are the right ones. So we'll kind of pick up on that here in a couple weeks. Anyway, hope you guys have a nice week. And hopefully this was a beneficial lecture for you guys. So I'll talk to you guys soon. All right, thanks.